solution, light dissolved like. When we put the sugar into water, they will dissolve. Sugar is the solute, water is the solvent. They form into solution. And when we ask, is all the solute dissolved in solvent? And in fact, that depends on one important factor. That is depend on the intermolecular force in between. And that is called the light dissolved light rule that we're going to go detail. The rules are very simple. They say if this is a polar solvent, it will dissolve polar solute. If it is a non-polar solvent, it will dissolve non-polar solute. Basically, polar dissolve polar, non-polar dissolve non-polar. As an example, sugar, polar. You can dissolve in water, polar. So they can dissolve. But if you push sugar into petrol, sugar, polar, does not dissolve in non-polar solvent, petrol. So the bottom one, it will not dissolve. And that is this light dissolve light rule. I'm going to go more detail about this light dissolve light rule because it's important. Polar solvent can dissolve polar solute. For example, water, H2O. H2O is a polar substance and it forms hydrogen bond between molecules. This stance needs further explanation. This requires you to rethink about early topic electronegativities causing a polar covalent molecule. Look at this polar covalent molecule, water. They are unsymmetric on electron distribution. That is more electron pull onto the oxygen. So you make oxygen more negative, hydrogen more positive. So because of that, water is a polar substance. Water is a polar substance. And this polar substance will cause hydrogen bond. That is, remember, because they have strong attraction between one and the other. So in between, this is the hydrogen bond. So in polar substance like water, they forming hydrogen bond between the molecules. So if you have the polar substance, any polar substance in water will dissolve. You put sugar into water, add salt, add orange juice, add Milo, add coffee, stir them all up, they all dissolve to each other. So they will all dissolve together because they are the same kind, like dissolve like. Now let's look onto the non-polar side. The non-polar solvent will dissolve non-polar solute. One typical example, oil. Oil is a non-polar substance. If you remember oil, they are made of hydrogen and carbon, hydrogen and carbon, hydrogen and carbon. This is oil. And in between them, they are dispersion force. Let's explain further. Go back to the electron negativities. Hydrogen and carbon, they have a very symmetric electron pooling. So all electrons go towards the center with no electron being distributed unevenly. So this makes it to be non-polar. This non-polar substance, so between molecule of non-polar and non-polar, there is an attraction force. This attraction force is the dispersion force. And this is much weaker attraction. So, if you put oil with peanut butter and add petrol, mix it all together, they will all dissolve. Or you add a bit of margarine, add a bit of butter, add a bit of petrol, they will all dissolve together because they are the same kind, the light dissolve light rule. So on summary, to compare polar solvent to dissolve polar and non-polar solvent dissolve non-polar, water and oil. Water, polar, they form hydrogen bond between neighbor molecule. So long as you are the same type, sugar, salt, apple juice, orange juice, all this dissolve. Oil, non-polar. They dissolve non-polar substance. They forming dispersed force in between. So if you put butter, add peanut butter, add margarine, add petrol, they all dissolve. So remember, polar substance form hydrogen bond between molecules. Non-polar substance form dispersion force between molecules.